So let's look at another example, finding the exact value of the cosine of 17 pi over 12 using the sum or difference identity for cosine. Now, because I'm looking to find two angles that add together or subtract to give me 17 pi over 12, I kind of put the unit circle here for you to be able to use as a reference. Now remember that if I'm trying to find two angles that add to give me 12, in order to add or subtract fractions, I have to have a common denominator. So you can see here with just a couple of these fractions that are showing in the top half of my circle that none of these have a denominator of 12, so I'm going to have to mentally convert, or maybe even write on this, all of these to a common denominator of 12, and then see which combinations would add together to give me 17 pi over 12. So I want you to take just a minute, because this is probably the most challenging portion of this particular example. Take a minute, figure out which fractions you would use to be able to add to 17 pi over 12, and then come back. Okay, so if I were to just figure out angles that added, not subtracted, which I could have done too, but if I just was focusing on two angles that added together to give me 17 pi over 12, you could have come up with possibly 3 pi over 4 and 2 pi over 3. Those two angles which occur here on the unit circle add to give me 17 pi over 12. Maybe you found 7 pi over 6 plus pi over 4, or possibly you found 5 pi over 4 plus pi over 6. Now there's more than just these three out there that could potentially add to give me 17 pi over 12, but these are typically the first three that come up whenever I'm going over this lesson. I'm going to use the cosine of 5 pi over 4 plus pi over 6, 5 pi over 4 plus pi over 6, and obviously this is the sum identity for cosine, to find the exact value of 17 pi over 12. So this becomes the cosine of the first, which is 5 pi over 4, times the cosine of the second, minus the sine of the first, 5 pi over 4, times the sine of the second, which is pi over 6. Now, the cosine of 5 pi over 4, this is in the third quadrant, and therefore the cosine of this would be negative square root of 2 over 2. And then pi over 6 is going to be in the first quadrant, which is the square root of 3 over 2. So minus, again, 5 pi over 4 is in the third quadrant, so this sign is negative square root of 2 over 2, and pi over 6 is just 1/2. So we multiply here, multiplying the leftmost product, I get negative square root of 6 over 4. And then because this is a negative times a negative, I have a positive square root of 2 over 4. So we can leave it like this, or we could even write it as negative square root of 6 plus the square root of 2 all over 4. Again, so the most challenging part of using the cosine sum and difference identity is just figuring out which two angle measurements could either add or subtract to give me the 17 pi over 12 that I'm looking for. So another example we want to look at is this right here. If I'm giving you the cosine of an angle times the cosine of another angle plus the sine of an angle times the sine of a different angle, you want to think to yourself, well, what is that? This is actually the cosine identity for the difference of the cosine identity, okay? So because this is a positive sign here, or because this is an addition sign here, I know that I'm looking at the difference identity where we have two angles separated by a subtraction sign, and I can rewrite this by saying, because I have two angles that are the same here, which would be 173 minus the second angle, which is 83. So 173 minus 83 is just 90. So I'm looking at the cosine of 90 degrees, which is just 0. So in this particular example, we went backwards. We started with the expanded form of the sum or difference identity, rewrote it as the difference of my two angles, and simplified it using that.